Hey guys, as I promised before, I'll be recording a class as a review for types of chemical reactions. Uh, the first reaction that we'll be seeing this time is synthesis reaction, and I will focus on the main type of synthesis reaction, the main rules. As I told you, it will focus on the ones that we need to actually combine and do in crisscross. And some others, like rule number 2 and 3, that I previously said in class that we were going to see it. The first reaction that we have occurs between aluminum and sulfur. As you know, aluminum is a metal, okay? And sulfur is in the part of the non-metals. In that case, we will be reviewing the first rule, metal and non-metal producing a salt, okay? So, but this rule overall is the main situation that you can do in the main process that you can follow in a synthesis reaction, that is a compound formation, crisscross, that we learned last year. Since aluminum is a metal that has a fixed charge of +3, I will combine it with the non-metal, which in this case is sulfur. Sulfur, when it's combined in an ionic compound, it has a charge of -2 and its name is changed to sulfide. So this is actually the ion sulfide. Since I have here the two ions, cation and anion, and the two charges, all I need to do is crisscross. So this 2 is coming to aluminum, while sulfur goes to egg along with the number 3. So with this you complete your chemical reaction, and all you have to do afterwards is balancing. First we start with metals and then the non-metals, and I have one of each in the reactants and I have 2 and 3 respectively in the products. As you can see, it's not balanced, and all you have to do is placing 2 in front of aluminum, and since I need 3, placing 3 in front of sulfur. Now my equation is balanced. In the second example, I have nickel 3 oxide combined with water, okay? And so in this one, since it's a synthesis reaction, we need to identify the type of compounds. In this case, we have nickel oxide, which is actually, nickel is a metal and oxygen is the ion oxide, refers to the ion oxide. So you are combining actually metal oxide with water, okay? According to the rules, whenever you combine metal oxide and water, it will be produced metal hydroxide. Metal hydroxide, okay? And since the metal in this reaction is nickel, okay, my compound will be formed with nickel. The charge of nickel in this case is the charge of 3, because remember, the charges, when you do crisscross, the charge that is opposite to the element is the one, the substrate that is opposite to the element is that one charge of the element. So in this case, this 3 from oxygen actually belongs to nickel, but as a charge. So in this case, nickel plus 3 is going to be our cation. Since it says hydroxide, I had to include the ion hydroxide as well. And the ion hydroxide is just OH with a charge of -1. All you need to do now is crisscross of the positive 3, and the charge of 1 is cancelled. So the compound form is actually nickel hydroxide and 3. Now to separate, remember that we must include parentheses. Now the equation is complete, and all I need to see is if it is balanced. As you can see, I have my reaction complete. I will separate this reaction from the one before a little bit more, just for the balancing process, okay? And we're going to list the elements as nickel, hydrogen, and oxygen respectively. And I have 2 nickels in the reactant, okay? I have 2 hydrogens in the reactant as well, okay? And I have 3 oxygens plus 1. In total, I have 4 oxygens. In the other side, I have only 1 nickel, 3, remember that the 3 outside parentheses multiplies everything internally. So you have actually 3 hydrogens and 3 oxygens. As you can see, it's not balanced. And I will start balancing nickel. Okay, to balance nickel, I place 2 in front of it. And now my nickel is balanced, but this also affects my oxygen and my hydrogen respectively. Okay, so what I do to calculate for hydrogen, I say 2 times invisible 1, and then I multiply by 3. So 2 times 1 times 3 gives me 6. And the same gives me for oxygen, 2 times invisible 1 times 3. As you can see, still not balanced. So I need to balance hydrogen because my nickel is balanced. So to balance nitrogen, the number that I need to place in front is 3 because 3 times 2 gives me 6. So with this, I have 6 hydrogens in the reactants, but this also changes my oxygen. Now I have 3 oxygens plus 3 times 1 is 3, and 3 plus 3 gives me 6. As you can see now, my oxygens is balanced. Therefore, all my reaction is complete. We move on to the next exercise. Okay, I have nitrogen and oxygen. Since the 2 of them are non-metals, this is actually a non-metal oxide combined with water. Okay, according to the rules, whenever I have a non-metal oxide plus water, is going to give me a ternary acid or oxyacid. Okay, so what we do right here is we're going to form a compound where we're going to have an acid where the oxidation state of nitrogen is the one from the same reactant. Let's see. In the reactant, you can see that from crisscross, we can assume that these 2 actually belongs to oxygen and that this 5 belongs to hydrogen. That's something that we know from compound formation by working in reverse, okay? As backwards. So 2 times 5 gives me 10, and negative 2 times 5 gives me minus 10, or negative 10, sorry. And as you can see, my compound is equal to 0, okay? So with this, I know that my charge of nitrogen is 5. Now, what should I do afterwards? I need to create, or I need to make an acid. How do I make the acid? How do I form this acid? It's going to be an acid, an oxyacid. An oxyacid including hydrogen, nitrogen, and oxygen. Okay, and I have two options for nitrogen and oxygen. I have nitrite and I have nitrate. Okay, so I need to find which one is the one that I'm using in this reaction. From where do I get this? From the table of the polyatomic ions. An oxyacid is an acid containing a polyatomic ion, and polyatomic ions are these two, okay? And these polyatomic ions contain the two elements that are in my non-metal oxide. So what should I do? I can make a oxidation number, okay, to find the oxidation state for nitrogen. So take a look over here. I take this first one and I say 1 nitrogen plus 2 oxygen. Since it's an ion, I will equalize to -1. Why -1? Because that is the overall charge of the polyatomic ion. So 1 nitrogen gives me just nitrogen plus 2, and I apply the rule for oxygen, that is -2 equals -1. Nitrogen minus 4 equals -1. You isolate nitrogen, this gives you -1 plus 4. So nitrogen in this case, using nitrite, gives you 3. But this one doesn't work for us. Why? Because we need the 1 nitrogen with a charge of 5. Okay, so what should I do now? Since it's not nitrite, okay, por descarte, it's going to be nitrate. But I want to confirm that it's nitrate. So I will do the same process. I have 1 nitrogen plus, and I have 3 oxygens. Since it is an ion, I equalize to the charge. So this is nitrogen plus 3 minus 2 minus 1. Nitrogen minus 6 equals -1. Nitrogen equals -1 plus 6. Nitrogen equals 5. So what I'm going to do? I'm going to make a compound, a ternary acid, that is going to have the ion hydrogen, that is this one, H+, with the polyatomic ion that I just did, NO3-, or nitrate. Since these two charges are plus and minus 1, they will be cancelled, and my reaction is gonna be just N2O5, or dinitrogen pentoxide, plus water, producing HNO3. HNO3 is nitric acid. Remember, I ate something eggy. I ate something eggy. So that's why we do this, okay? And now all you can see is that the equation is complete and we're going to balance. So that's the product. The product is going to be an acid, and the balancing part is going to be very simple. Nitrogen, hydrogen, and oxygen. I will separate my last reaction. Okay. So in the reactants, I have 2 nitrogens, 2 hydrogens, and 5 plus 1, 6 oxygens. In the products, I have 1 nitrogen, 1 hydrogen, and 3 oxygens. As you can see, it's not balanced. What I have to do now, I have to balance. I need to balance my nitrogen, and to do that, I just need to place 2 as a coefficient, and this multiplies everything. 2 hydrogens, 2 nitrogens, and 2 oxygens, that gives me 6. And after this, my equation is balanced. So this one is a little tricky, but it's actually the opposite that we do for decomposition. Decomposition of acids is exactly this, but in backwards. And now here we have silver and oxygen. Oxygen, when it's alone, remember, is diatomic. Now, I'm going to give you a key. Anytime you see that you have lone elements, like we have over there, just silver and just oxygen, or like we had in the beginning, okay? In the beginning, we had just aluminum and just sulfur, okay? So whenever we have reactions like this, remember, we are just gonna do compound formation regardless the rule, okay? So, compound formation between these two elements will be aluminum, sorry, not aluminum, because it's not aluminum, it's silver, sorry. Silver, the charge of silver, according to the periodic table, is +1. And you will combine it with oxygen. Oxygen, that is -2. The charge of +1 is cancelled, and the one of 2 is coming to the side of silver. In total, this is the final reaction that I get. Silver oxide and the 2 between silver and oxygen. Okay? Now, what do I have before? I have to just complete the reaction, Ag, or silver, plus oxygen as a diatomic molecule. And this is what I have. And now, what should I do? I need to check if it's balanced. By a very simple inspection, you can notice that it's not balanced. Okay? Silver first, oxygen after, 1 and 2, 2 and 1, not balanced, so I need to balance, starting with silver. Silver is 1 here, so to balance I put a 2. And in the other side, I do the same. I have just 1 oxygen and I need 2, so I place 2. But this, look at this. This changes my silver. Silver now is 4 and oxygen is 2. Oxygen is balanced, but this actually changed my silver. Now, I don't need 2 silvers anymore, I need 4. So I erase the value that I had before and I place 4 instead. And now my equation is complete. So this is it about synthesis reaction. I could give you more examples, but that would take more time, and just follow the rules, guys. In the end, overall, it's the same. Just follow the rule, do compound formation and balanced. After this, you have this combustion reaction, that is your favorite type of reaction. And the first one that I have over there is a hydrocarbon with 7 carbons. This one from here is called heptane. Okay, so how do you recognize a combustion reaction? It's a CHO. Okay, and all CHO reactions produce CO2 and water. So the product is very, very simple to predict. That's it, that's the product. All you have to do now is balance. Remember, to balance, you have your CHO. I'm gonna move it here, okay? And you have 7 carbons in reactants, 16 hydrogens, 2 oxygens, and here 1, 2, 3. Okay? To balance carbon, I just need to place 7 over there. Gives me 7. Okay, now to balance hydrogen, I need 16, so I need to place 8 to have 16. 8 times 2 makes 16, and in total now I don't have 3 oxygens. I have 3 times 2, that is 14, plus 8 and 2, that is 8 and 1, sorry, that is 8. 14 plus 8 gives me 22. In order for having 22 oxygens in the reactants, I place the number 11, because 11 multiplied by 2 gives me 22. And my equation is balanced. Here I have another example, another CHO. Okay, in this case I have dodecane, okay, because it's 12 carbons. So the product will be the same, CO2 and water. Since it's a CHO, we need to balance carbon 12, 26, 2 and 1, 2, 3 in the products. To balance carbon, I place 12. To balance oxygen, I place 13, because 13 multiplied by 2 gives me 26. So now all I need to do is balancing my oxygen. In the first part, 12 times 2 gives me 24. And in the second part, gives me 13 times 1, 13. Okay? And 24 plus 13 gives me 37. In this side of the reaction, in order to have 27 oxygens, as you can see, all I need to do is I take this 37 that I need and I divide by 2. So I say 37 divided by 2. Okay, so that gives me 18.5. I might be wrong, okay, don't trust me, but it should be 18, because 18 times 20, yes. So, when you divide, gives you 18.5, and 18.5 is 37. My equation now is balanced, but as you know, we cannot leave just the reactions with decimals, okay, like we have it over here. We cannot just leave it there. So all we have to do now is we need to multiply all my reaction times 2, okay, and as a result, this is what I have: 2 dodecane plus 37 diatomic oxygens, producing 22 carbon dioxides and 26 waters. So that is going to be my final reaction, already balanced. And that's it, guys. You know that is very simple, that your reactions are like a gift from life. Let's see, we have decomposition reaction now, and I'm going to explain only 3 rules. The first rule, that is for carbonates, okay. The second rule, that is for chlorates, and the third rule, that is for, let's see, acids, okay. So the first one is a carbonate. How do I recognize it's a carbonate? Because it has the polyatomic ion carbonate in it. How do I recognize chlorates? Because this one is chlorate. How do I recognize acids? Because acids start with H2. Well, not H2, hydrogen in general. Okay? So that's how I recognize a decomposition reaction. Another way to recognize it is because, as you can see, the 3 of them are just one single reactant. Okay, so, and this reactant is a combination of ions. Okay, it's a complex compound. It's not a very simple compound. So what do we do? Okay, for carbonates, the rule says that carbonates will break down into carbon dioxide and element oxide. That is a rule. So which one is going to be my element? My element is going to be my first element. Okay, so my product, this is going to be CO2 plus chromium. Since chromium is a metal from the transition metals that has multiple charges, I need to identify its charge. The charge for chromium here is 3, because remember, whenever we do crisscross, okay, and we work backwards, it's very simple to identify that this chromium is actually chromium plus 3. Okay, so the charge of this chromium is plus 3, and I will combine with oxide. oxide ion that, as you know, is oxygen with a charge of -2. So in here, you do your crisscross because we cannot cancel, and the compound form is Cr2O3 plus CO2. So CO2 and chromium 3 oxide, these are my products. Okay, my products of the reaction Cr2CO3, decomposition of chromium 3 carbonate. Now what do I have to do? I need to balance. Okay, so I'm gonna list my elements: chromium first, carbon after, oxygen afterwards. And I have 2 chromiums, and I have 3, and I have 9. In the products, I have 2 chromiums, I have 1 carbon, and I have 2 plus 3 or 5 oxygens, which is not balanced. My chromium is already balanced, though. All I need to balance is my carbon. So to balance carbon, I place 3 in front. This balances my carbon, but also changes my oxygen. 3 times 2 makes 6, and you have 3 from the other side. Now my equation is balanced. In the other side, I have the second reaction. I have manganese 4 chlorate. Manganese 4. This charge, this subscript, sorry, is the same, okay? It's the backward process of crisscross. So that means that this manganese is actually manganese plus 4. So that is the charge that we are going to using for manganese. So according to the rules, chlorate will break down into oxygen gas, and oxygen gas is written as O2. Oxygen gas. Plus, we're going to form element chloride. Which one is going to be our element? Is going to be the first element from the reaction. In this case is manganese. We already identified the charge. All we need to do is complete the reaction. So this is O2 plus element, that is manganese 4, combined with chloride, which is -1. We do crisscross, -1 is cancelled, and the 4 comes to the opposite side. So my total compound form is this one, O2 plus manganese, chlorine, and 4. So this is the decomposition of manganese 4 chlorate. All I need to do now is I need to balance. Okay, I will separate my reaction. There you go. So I have manganese first, chlorine after, oxygen the last. I have 1 manganese. I'm going to separate this a little bit. Give me a chance. Okay. Okay, 1 manganese, 4 chlorine, and 12 oxygen. In the products, I have 1 manganese, 4 chlorine, and 2 oxygens only. So manganese and chlorine, as you can see, they are already balanced. All I need to do is I need to change my oxygen. In order to get 12 oxygens, the number I should place is 6, because 6 times 2 gives me 12, and this is already balanced. Now the one that is a little bit more tricky is the one of acids. Okay, for acids, let me do this. For acids, we are doing the opposite process that we did first in synthesis. According to the rule, it says that acids will decompose into water. So water is the first product, or second, it doesn't really matter. And then it says molecular oxide. Molecular oxide, that means that is a non-metal oxide. Okay, but in this case is a metal because it's the element in the middle. That's interesting. But the rule applies in the same way. Since chromium, remember that chromium acts also like a non-metal, because non-metals have multiple charges. In this case, chromium, we need to find its oxidation state to find this molecular oxide. So what I do first, I'm going to make my oxidation number process. So I say oxidation number H2Cr2O7. Okay, so I say I have 2 hydrogens plus 2 chromiums plus 7 oxygens equals 0. The rule for hydrogen is 1. The rule for oxygen is negative 2. 2 times 1 is 2. I subtract. I isolate. And I isolate. And gives me that this chromium actually is chromium 6. Okay, so I start creating my product. I say that the first product is HO2, and this molecular oxide is gonna be chromium with a charge of 6 that I found with oxidation state, and combined with oxygen that is negative 2. Since the two numbers are divisible by 2, I'm gonna have to simplify afterwards. Okay, so let's do this. Chromium is going to be with 2 and oxygen is going to be with 6, and then this will be simplified into 1 and 3, and 1 is invisible, so this gives me as my product. Okay, so this is the product prediction that we did. Now let's see the balancing process. Okay, first chromium and oxygen, hydrogen and oxygen. So 2, 2, 7, and here I have 1, 2, 1 plus 3 or 4 oxygen. I start balancing chromium by placing 2. This gives me 2. Okay, but this changes my oxygen, giving me 1 in one side and 6 in the other side, 7, which indicates that my reaction is balanced. I have to be honest, when I wrote the dicarbonic acid, I was not thinking of the rule of the molecular oxide, but just follow the rule, okay? If it's chromium, you do it like this. If it's nitrogen, you do it like this as well. It doesn't really matter, as you can see. The product was predicted, and now you can see the reaction is complete. And that will be it for decomposition. Now comes single displacement, and for single displacement, you need to use the table of the one that I sent to the group, okay? The reactivity table. In the first one, you have the element tin combined with water. Too bad that I didn't include the. Well, I can place it here. Okay. Okay, sorry. The recording stopped. But there you go. You have the table, so you can actually see how we use it for this type of reaction. Okay. In the first one, I have tin combined with water. So what I do, I look for the element tin in the table. My element tin is here. Okay, and it's combined with water. So the first thing that I read is this part. It says, do not react with water. And there you go. You stop right there because you don't need to do more. So in this case, for this specific element, and also for these ones from here, the rule applies the same. Okay, they do not react with water, and all you need to write here in the reaction is no reaction, work is done. That's it. In the second reaction that you see here, I'll move it here. Okay, I have zinc and I have sodium, and the idea is the lone element is gonna try to replace the element from the other side. If it's a metal, the one that we replace is a metal. If it's a non-metal, the element alone, the lone element, is going to try to replace a non-metal. In this case, we have a sodium, and I have zinc. So this is what I'm gonna do. I will see how these two are located in the table. So the element alone is sodium, and this one is trying to replace zinc. As you can see, sodium is above zinc, okay? So yes, is capable to replace it, and since it is capable to replace it, all you have to do is compound formation. Now zinc is alone. It was supposed to be green. Yes, my bad. So now zinc is alone. Since it's not a diatomic molecule, I'm not going to write a subscript. And in the other side, I'm going to have my sodium, okay, combined with the polyatomic ion that you have in parentheses there, that is arsenate. Arsenate has a charge of -3, and sodium has a charge of +1. What you're going to do is simple crisscross. Now I'm going to erase the circles, and I will do my crisscross. I will complete my crisscross. So I have zinc plus sodium 3 arsenate. And in the reactants, I have the exact same reactants from the beginning. Now, the other day I was telling you that you need to take advantage every time you have parentheses. Parentheses helps you a lot to balance faster. So I see that my arsenate here is multiplied by 2. Okay? So in the other side, I will multiply my same arsenate, or the side where arsenate is, I will multiply by 2. How? By placing a 2 right in front of it. And I will start my balancing process. I have zinc, I have arsenic, and I have oxygen. I have 3 zinc, I have 2 arsenic, and I have 8 oxygens. In the other side, I have 1 zinc. I had initially 1 arsenic, and I have 4 oxygens. But after, I forgot sodium. I forgot sodium, sorry. I'm going to place it now. Let me make the arrangement. Qué barbaridad. Okay, sodium in the reactants is 1, and in the product it was 3. But after multiplying by 2, you have 6 sodiums. After multiplying by 2, you have 2 arsenics, and after multiplying by 2, you have 8 oxygens. So the only thing I need to do is to balance zinc. Now my zinc is balanced. I have 3. And in the other side, just to balance, I need just to add a 6 in front of sodium, and my sodium is balanced. My complete reaction is balanced afterwards. And that's it. Okay, I will bring this table, and I will delete this because I don't need it anymore for my further exercises. In the third example, I have a lead, okay, and nickel 3 sulfate, okay. So I need to locate lead, which is here, and nickel, that is here. So lead, the lone element, is going to try to replace nickel in this case. The lone element is located at a lower position, so this cannot occur because a lower position cannot replace a greater position, a higher position, sorry. So in this case, the reaction won't take place. Very simple, just write no reaction there. And in the last example, you have iron plus phosphoric acid. So you're going to see if iron is capable to replace the hydrogen from the acid, okay? So your iron is right here, and hydrogen is over there. So by the position, you can see that iron can replace hydrogen. But we also can see the rule. It says that iron is in the group that reacts with steam and acids. So yes, it will react with acids. Doing what? Replacing hydrogen. Okay? So that's exactly what we're going to do. My iron will replace hydrogen. So I will have hydrogen alone as a product. Since it's alone, it's going to be diatomic. And my compound is going to be iron combined with phosphate. Phosphate is -3. Here I didn't specify the chart, but I'm going to work with iron too. Okay? So I will say +2. Now all I need to do is crisscross. And my product form is iron 3, phosphate, and 4, and we need to place a parenthesis. We complete the reaction, and this is what I have. Now all I have to do is balancing. So I list iron first, phosphorus, hydrogen, and oxygen. Okay, 1 iron, 1 phosphorus, 3 hydrogens, 4 oxygens. In the products I have 3 irons, 2 phosphorus, 2 hydrogens, and 8 oxygens. As you can see, it's not balanced. I start with iron by placing 3 in front, and now it's balanced. Phosphorus, I need it to be 2, so I place 2, and my phosphorus now is balanced. Hydrogen, I don't have 3 anymore, I have 6. In the other side, I just have 2, so I need to balance by placing 3. Now I have 6 hydrogens, and now I don't have 4 oxygens anymore, because this 2 multiplies everything, okay, by distributive property. So this 2 times 4 gives me 8 oxygens. In total, everything is complete, and we can see that is balanced. And in the last part, we have the double displacement reactions, which I consider that are very, very simple. Because in double displacement reactions, all you have is crisscross and then balancing. But to know crisscross, you need to know. You really need to know. Okay, so let me show you. Let me help you know about it. In the first one, you have, sorry, my cations are gonna be blue. Cations are always the first element in a compound, okay, in ionic compound, and the anions will be the second element. So what happens in this kind of reaction is that these cations are going to switch places, okay? That means the iron will replace aluminum in the first compound. So this iron is iron 3 because of the opposite charge that is in the other side. Okay, so one product will be iron plus 3 combined with the first anion, that is SO4. And the second product will be the first cation. Aluminum is always plus 3 and it's combined with the second anion, that is carbonate. So here what we do is crisscross. Here I'm changing the colors because I want you to associate cations to be blue and anions to be red. And here I do my compound formation as iron 2 SO4 3, separate with parentheses. The second compound will be aluminum 2 CO3 carbonate 3, that is a 3, and I separate by using parentheses. And I complete my reaction. I don't need this anymore, so I erase it. And then I will simply balance. So I have aluminum, iron, carbon, sulfur, and last one will be oxygen. So aluminum is 2, iron is 2, carbon is 3, sulfur is 3, oxygen is 12, plus 9, and the other side 21. Sorry, I was processing. In the other side I have 2 aluminums, 2 iron, 3 carbon, 3 sulfur, and oxygen I have 12 plus 9 equals 21. So this equation is balanced. I didn't have to add anything else. This equation was already balanced. In the second example, as you can see, is magnesium phosphate and sodium nitrate. Again, my two cations will switch places. So my magnesium is going to be with nitrate and my sodium will be with phosphate. So my first compound is sodium with a charge of +1 from the periodic table, and then I have PO4, that is phosphate, with a charge of -3. My second compound though will be magnesium cation. Magnesium is always +2 according to the periodic table, and the anion will be NO3 -1. So these charges of +1 and -1 are getting cancelled, and I will only crisscross the one of 3 and the one of 2. My first compound is sodium 3, and then the phosphate, and the second compound is magnesium nitrate, separate by parentheses and then 2. The two compounds are separate, and I complete my reaction. Magnesium 3, PO4 2 parentheses plus sodium nitrate, and then I check if it's balanced. Magnesium and sodium are first, then phosphorus, then nitrogen, and then oxygen. Okay. Then I balance. I have 3 magnesium, I have 1 sodium, I have 2 phosphorus, I have 1 nitrogen, and I have 12 plus 3 equals 15 oxygens. And in the other side, I have 1 magnesium, 3 sodiums, 1 phosphorus, 2 nitrogens, and 4 plus 3 times 2 is 6, only 10 oxygen. As you can see, it's not balanced. So I'll start with magnesium, placing 3. Okay, now it has 3 magnesiums. And then I place 3 in front of sodium. Okay. Since I need phosphorus to be 2, I place this 2 over here. And this gives me 2 phosphorus, but this changes my sodium. I have 6 sodiums now, which means that I don't need 6 sodiums, 3 sodiums there. Instead, I need 6, because this still need to be balanced. Nitrogen. Nitrogen in the reactants, I have 6, okay, and in the products, I have 3 times 2, 6. I have now 12 oxygens plus 18 from the second part, and I have 30 oxygens. In the products, I have 12 from the first one, and 3 times 2, 6 times 3, 18, a total of 30 oxygens. All numbers match, so it's balanced. And then the last one, I have chromium oxalate, chromium 3 oxalate, and lead 4 nitrate. Okay, I do the same process. I identify my cations, and those are my cations. Remember, the opposite numbers are the charges. So in the first compound, I will have lead with a charge of 4 combined with the first anion, that is oxalate, C2O4 with a charge of -2. And then I have my second compound, that is going to be my first cation, that is chromium 3, combined with my second anion, that is NO3 minus, or -1. Okay, so this -1 is cancelled, and here crisscross, and here I crisscross the 3. So I have PV, or lead 2, C2O4, 4. Now 2 and 4 are both divisible by the same number. That means that they need to simplify. 2 becomes 1 and 4 becomes 2. And 1 is invisible, so the first compound will be PV invisible 1, parenthesis C2O4, parenthesis 2. The second compound will be chromium, nothing after chromium, NO3, parenthesis 3, to separate. So the second compound is this one from here. And I complete my reaction by writing my reactants. Then, of course, I will balance. And I do the same. Chromium, lead, carbon, nitrogen, oxygen. 2 chromium, 1 lead, 2 times 3, 6 carbons, 4 nitrogens, and 12 plus 12, 24 oxygens. In the products, I have only 1 chromium, 1 lead, 2 and 2, 4 carbons, 3 nitrogens, and 9 oxygen. Is now balanced. So I start with chromium by placing 2. Chromium is 2. Okay, but this changes my nitrogen. Is not 4 anymore. I have 2 times 3, 6 carbons. Sé que dije carbons, ok, pero espérense, que era nitrogen. It's not 3 anymore, it's 6 nitrogens. And it's not 9 oxygens anymore, it's 8 plus 18. That is, oh, I had more oxygen. Okay, 8 plus 18 gives me 26. Okay, still not balanced. I need to balance carbon. I need carbon to be 6, and I have 4. I can multiply by 1.5 because 4 times 1.5 gives me 6. Or I can say, I could do like I said before, okay? That whenever you see a parenthesis, you need to see an opportunity to balance faster, and that's what I'm going to do instead, because I'm already tired of working like this. Okay, so this 3 from oxalate is here in the other side where I have oxalate, and this 2 from oxalate, I place it here in front of the other oxalate. Okay, the 4 from nitrate, I place it in the other side where I have nitrate, and this 3 from nitrate, I place it in this side. Now I will check that it's balanced. Okay, look at this beauty. Okay, I have 4 chromiums. Okay, I have 3 leads. I have carbon, sería 3 times 2 times 2, sería 12 carbons. 2 por 2, 4 por 3, 12, ya, 12. And let's see, nitrogen. Nitrogen sería 4 and 3, 12 nitrogens. And then oxygen sería, instead of 26, sería 3 times 2, 6 and 4, 24. Plus the second compound will be 3 times 3, 9 times 4, 36. 36 plus 24 is 60. And in the reactants, I have to update it. 4 chromium, 3 lead. Okay, now let's see carbon. Carbon sería 2, 2 and 3. 2 por 2 por 3. 2 times 2, 4. Times 3 sería 12. Let's do the same for nitrogen. For nitrogen sería 3, 1 and 4. 3 times 4 is 12. Y para oxygen sería 3 and 4 sería 12 de este compound, and from the other compound will be 4 and 3, 12 times 2, 24. Okay, it's not balanced. Vamos a ver. Ah, sorry, I messed it up here. It's okay. In the first one here, I have 3 times 3 times 4. 9 times 4 is 36, and 36 plus 24 is 60. I was so afraid that it was not balanced, but now yes, I fixed it. So that will be it, guys. This is a review overall of all type of chemical reactions. We review everything from balancing to compound formation to oxidation number. Okay, oxidation number like we did here, or like we did in synthesis. We also review the Cho reactions, and that's it, guys. Have a nice weekend.